Hello everybody. In today's lesson, 2.2G, we're going to look at how to convert decimals to fractions. This is the WAMAP page. We'll just work through these very quickly. We're going to change this fraction, 0.017 or 17 thousandths, to a fraction. All right, let me grab my tablet and we'll see what we can do. All right, so when we want to convert a decimal to a fraction, it's very useful if we know how to read them. So one way to read a decimal is just to read the numerals 0.017, and the other way to read them is to read this as a regular number up to the decimal point, and then the decimal point is read and then you read this as a regular number up to the end of the number, and you use the name of this column as your units for this last column. So 0 and 17 thousandths. You could also leave off the leading 0 and just say 17 thousandths. So we read this number as 17, and the 7 is in the thousandths column. So you can write that. If you know how to read that, then you can write 17 thousandths as 17 over 1,000. Okay. So this is this decimal written as a fraction becomes 17 over 1,000 or 17 thousandths. And then the only thing we have to consider is reducing this fraction. And if you know your first 10 prime numbers, you'll know that this number 17 is prime. And the number 1,000 doesn't have 17 as a factor. What you can do is do a prime factorization on these. So 17 is just 17. So let's look at the number 1,000. We'll do a quick prime factorization. 2 to 500, 2 to 250, 2 to 125. And then 2 won't work anymore, so let's use 5. 5 goes in there, 25 times? And then 5, and then 5. So we have, for 1,000, we have 2 times 2 times 2 over 5 times 5 times 5. So none of these prime factors contains a 17. So we know that this number, factors of 17 are just 1 and 17. And factors of 1,000 are 2 and 5. So no factors in common. So this is completely reduced. Let's take a look at our next number. 0.198 is one way to read this. Also 0 and 198 thousandths. So if we write that out, 198 thousandths, then we can see if we need to reduce this. And some of you may have already noticed these are both even. So we should divide them both by at least 2, possibly 4. And if you know your divisibility rule for 4, you can determine if 4 goes into 98 evenly. And unfortunately, it does not. So 4 won't work, but let's try 2 and see how far we can get. Let's divide the top and the bottom, the numerator and denominator, by 2. And we're going to get 99 and then 500. And this may be as far as we can go. Factors of 500, let's try it. Let's do a prime factorization of 99. We'll get 3 and 33, and then 3 and 11. So our prime factors here are 3, 3, and 11 for 99. And then if we do a prime factorization of 500, we can just pick it up from this. We have 2 times 2 times 5 times 5 times 5. So that's 2 squared times 5 cubed. There's no 2 or 5 here, so these will not reduce. They don't share any factors in common. So this is as far as we need to go, 99 500ths. So this is, we've been working on this prime factorization process. It makes it quite easy to line these up. And before we were lining them up like this. So for the first one, 17 over 2 times 2 times 2 times 2. Oops, that's one too many. Let's make this a 5 times 5 times 5. And we can cancel out any that are shared, but there aren't any. So we're just going to go back and multiply these all together, and we'll get 1,000 in the denominator and 17 in the numerator. Okay. Same thing down here. we can write this as the prime factorization of 198 is 3 times 11 over, and then we have 2 times 2 times 5 times 5 times 5. And there are no factors in common here. And if we want to back this all the way up to 198, we would just add another 2 times here, right? 2 times this and 2 times this. And now we do have 2 in common. So this is 198 over 1,000. So when we cross out the one pair of 2's they have in common, then we get 3 times 3 times 11, which is 99, and 2 times 2 times 5 times 5 times 5, which is 500. Okay, so give these a try, and if you run into trouble, send me a message. Good luck.